Now, a couple of things that you should notice. First of all, as you can see, I'm wearing gloves and I'm not touching this metal right away. Sorry, the quality is just okay. And so I'm taking this metal out of this container. By the way, in this container, I have oil. And this is sodium, a piece of sodium that I've taken out. So a couple of things that you might notice is, first of all, I'm wearing gloves. The piece of sodium was dissolved in oil when it was inside. Why do you think that was? Why am I
Sir,
wearing
which
gloves?
chapter is this?
It's not entirely one chapter because I have my own order of topics from the syllabus, but today will involve metals, uh, redox, and periodic table. All three of them combined in this. Okay, so first of all, why am I wearing gloves?
For safety precautions.
What safety precaution? Be specific. हो सकता है ये
It
metal
is
मेरे
reactive.
it is reactive with my skin, right? And that is why I need to wear gloves. Why is this dissolved in oil?
Sir, this is dissolved in oil because all group 1 metals are very reactive with water and oxygen.
Very good. So because if it wasn't in oil, then it will react with oxygen in the air. And I don't want that. I want to keep the metal as it is. So, okay, so here we go. So I've closed it again because I don't want oxygen to go in there. And this is water. I was just getting it ready for the reaction. Okay. Now here I have that piece of sodium and it's a metal, but it will behave in ways that we don't really expect metals to do. So here's what I'm going to do. Just a small bit of force and notice that I've cut it out, right? It is so soft. I was able to cut it out just by a small force, as you can see over here. Sorry. And do you see a change in color? Look at the fresh piece or fresh side that comes out. Do you notice anything in there? Do you notice something about it? Like there's one side that is yellow and one side that is grayish or silvery, right? That is how metals are. When they haven't reacted with air or when they're just fresh, they are shiny. And the fresh side that you have, it will quickly react with oxygen in the air. It will turn slightly grayish because it reacts with the oxygen in the air. And I'm adding it to water. What do you see? What's happening? Observations.
Fizz.
There's fizzing. There's a small cloud over there, right? The
It
white
is
one.
floating.
It is floating. Very good. It did not sink. What else? Did you see small sparks flying around? So why is this floating? Why is this fizzing? There must be some gas coming out, and that gas is there. Again, I'm doing this again, but this time I'm reacting it with acid. So there you go. Notice this side of sodium, it's really shiny, grayish, very straight edge that shows that there's a layer in there. So all of those things we can make observation of what the metal is like. It is soft, it is floating, so it is low density, and it is shiny. Now let's see what happens now. So I'm going to add this to acid. So I added it to water because I wanted it to cool down right away. Any observations about that reaction, the one that we had with the acid, this one? Any observations here? The moment I add, there's a lot of bubbles, as you can see. And then there's metal still floating on the surface. And then there's a spark. There's a lot of that oxygen, hydrogen gas coming out. And there you go. It's explosive. In a large quantity, hydrogen will be explosive. And there's a high temperature, actually. It's a very exothermic reaction. And to cool it down, I added it to water. But let's see how other metals do this. So now I have HCl and I'm going to add magnesium into that. Do you see anything here? Any bubbles?
Black ribbon of magnesium.
There are some small bubbles if you notice. थोड़े से bubbles आ रहे होंगे. थोड़े से. Now this one is magnesium. That was copper, by the way. This one is magnesium. Okay, see, so I added magnesium there. And okay, here you go. So we wanted to test if the hydrogen gas was there or not. Lekin hame koi as such pata nahi laga. This is how you test for hydrogen gas, by the way. You take a burning splint and you bring it close to that, and there will be a pop sound because of this. Okay. And do you notice that there's a lot of fizzing there? There's a lot of bubbles there, as you can see over here. This is magnesium reacting. Copper के साथ कोई bubbles नहीं थे. यहाँ पर there's a lot of bubbles coming out. Okay, do you see them? But they are not as fast or as frequent as it was with what you call sodium. So what does that tell us about how sodium and magnesium and copper compare to each other when it comes to reacting with water or reacting with acids? What does it show, this whole observation that we had? First of all, what does it tell us about group 1? It tells us that group 1 elements are soft, they have low density because they were floating on water, right? Although this tells us just about sodium, but I can tell you that all group 1 metals behave like this. They're highly reactive. They react with oxygen in the air. They react with water rapidly. With acid, बहुत rapid reaction हो रहा था. But that wasn't the case with copper. बिल्कुल ही नहीं हो रहा था. And that with magnesium, the reaction was there, but not as fast or as rapid, right? Similarly, it was releasing a lot of bubbles, a lot of hydrogen gas when it reacted with water. ठीक है, that is there. But all of this stems from one basic idea, which is displacement principle. Displacement principle is really simple. A more reactive species, and in our syllabus it will be the element, displaces a less reactive species. In our case, our syllabus, it's going to be ion. So more reactive element displaces a less reactive ion. That is the displacement principle. But how do we see it? हमें क्या पता कि वो less reactive है या more reactive है? उसके लिए we usually use what we call reactivity series. And reactivity series is usually written like this. This is usually how it's done. Similarly, for non-metals, you also have this one. I would move chlorine a little down. OH minus. OH is sometimes written here or sometimes written below iodide here. But we will consider it like this. That's good enough for us. What is this telling me? Reactivity series. We usually tend to think of this, Ketchup. Things at the top, they are more reactive, and things at the bottom, they are less reactive. That's usually what we think about it. But what does it even mean to be reactive? Like, do you remember redox reactions for ionic bonding when we talked about them? In terms of electrons, what is oxidation? Go on, tell me. What is oxidation?
Loss of electrons.
Loss of electrons. So when something loses electrons, we say it is oxidized. And we usually say that metals oxidize. Metals lose electrons. Okay. In terms of electrons, what is reduction?
Gain of electrons.
Gain of electrons. Something gains electron. When we usually say non-metals gain electrons. Now tell me one thing. Do metals gain electrons? Do non-metals lose electrons?
Yes, they do.
Non-metals losing electrons. They do. Where have you seen this? Do you know of any reaction where non-metals will lose electrons?
No.
With metals, they usually can't. Like if there's a metal wins when it comes to losing electrons. But what if there was a metal and another metal, and I wanted them to react? One of them was ion, one of them was atom. One wants to lose electrons. Will the other gain electrons? That is what we are going to talk about today. I know कि हमें बचपन से एक रट्टा लगवाया जाता है that metals lose electrons and non-metals gain electrons. I want to destroy that ratta. क्योंकि रट्टा नहीं चलेगा. We are going to build some concepts here. Metals can gain electrons, metals can lose electrons, non-metals can gain electrons, non-metals can lose electrons. और आज मैं आपको दिखाऊंगा कि कैसे होता है. Basically, whenever we say that something reacts, we say कि वो या इलेक्ट्रॉन ले रही है या इलेक्ट्रॉन दे रही है या कुछ इस तरह से रिएक्शन हो रहा है रिडॉक्स रिएक्शन में खास तौर पे. But that does not mean कि हर चीज बस इलेक्ट्रॉन दे रही है और एक टाइम पे बस उसने देने ही है. That's not the case. It's always a competition. Electrons are expensive. They are the currency of atomic world. So they are expensive. उनको लेने के लिए देने के लिए you have to spend energy. You have to take energy to do all of that. So when we say something is more reactive, we are saying it is able to use electrons with less energy. Energy पैसों की तरह होती है. हम पैसे खर्चते हैं, हमें कोई चीज मिल जाती है ऑफ वैल्यू. इलेक्ट्रॉन इज द वैल्यूएबल थिंग दैट एटम्स आर आफ्टर. अगर किसी को बहुत ज्यादा पैसे खर्च करके कोई चीज मिले तो हम उसको महंगा समझेंगे ना. जस्ट लाइक दैट किसी एटम को बहुत ज्यादा एनर्जी स्पेंड करके कोई इलेक्ट्रॉन मिले तो वो एक लेस रिएक्टिव चीज. वी डोंट वांट दैट. इट्स नॉट गुड एट गेनिंग अ बार्गेन. But if something requires less energy to do that, we say it's more reactive. And it all depends on how the atom is like. Small atoms are better at reduction, worse at oxidation. Why? Because if you have small atoms, तो उसकी अपनी force of attraction with the last electron काफी strong होगी. तो अगर उसको इलेक्ट्रॉन लेना होगा तो वो आसानी से ले सकता है क्योंकि इलेक्ट्रॉन के साथ उसकी अट्रैक्शन स्ट्रांग है. बट अगर इलेक्ट्रॉन लूज करना है तो वो इतनी आसानी से कर नहीं पाएगा. That is why when we take sodium and fluorine, fluorine is a smaller atom, sodium is a bigger atom. How do I know about that? From the periodic table. Fluorine is in period 2, 2 shells हैं उसके पास. Sodium is in period 3, उसके बाद 3 shells हैं. और उस वजह से सोडियम आसानी से इलेक्ट्रॉन लूज कर सकता है और फ्लोरीन आसानी से इलेक्ट्रॉन्स गेन कर सकता है क्योंकि उनका साइज इस तरह से है. ऑफ कोर्स देयर आर अदर थिंग्स एज वेल. बट डज द सेम थिंग अप्लाई टू मेटल्स? यस, यू बेट इट डज. पोटेशियम इन द पीरियोडिक टेबल, पोटेशियम इज बिलो सोडियम. पोटेशियम इज इन पीरियड 4. इसके पास 4 शेल्स हैं. इसका जो लास्ट इलेक्ट्रॉन है वो चौथे शेल में है. सोडियम इज इन third period. इसका last electron is in the third shell. So obviously potassium की attraction is weaker. potassium बड़ा atom है, sodium छोटा atom है. potassium को electron lose करना आसान लगेगा, attraction कम है ना. sodium को electron gain करना आसान लगेगा. Do you get it? sodium को electron gain करना आसान लगेगा, it's a smaller atom. potassium के लिए electron lose करने में कम energy लगेगी, वो आसान है. So when we look at reactivity series, we are not saying कि ये सारी चीजें इलेक्ट्रॉन गेन करती है, इलेक्ट्रॉन लूज करती है. हम कहते हैं the things at the top are better at losing electrons. The things at the bottom are better at gaining electrons. The things at the top are better at oxidation. The things at the bottom are better at reduction. Group 2 में देखो, calcium is in group 2. It has 4 shells. Magnesium has 3 shells. It's not a coincidence that calcium ऊपर है, magnesium नीचे है. Calcium will find it easier to lose electron क्योंकि बड़ा atom है. Magnesium is a smaller atom. It will find it difficult to lose electrons when compared to calcium. इसी तरह between sodium and calcium, sodium wants to lose 1, calcium wants to lose 2. So 2 वाले को energy ज़्यादा spend करनी पड़ेगी. It will be less reactive than sodium. So atomic size comes into play. The group number comes into play. But at the heart of it, it is all just कौन कितनी आसानी से oxidation कर सकते हैं, कौन कितनी आसानी से reduction कर सकता है. So where do we see it in the real world? Like हमें नजर कहाँ पे आता है ये चीज? अच्छा, non-metals में we look at the reduction side. Fluorine is better at reducing क्योंकि fluorine छोटा atom है. Chlorine is better at oxidation compared to fluorine. So जो नीचे होंगे वो इलेक्ट्रॉन लूज जल्दी करेंगे, जो ऊपर होंगे वो इलेक्ट्रॉन गेन जल्दी करेंगे इन नॉन मेटल्स. यहाँ पे जो ऊपर होंगे वो इलेक्ट्रॉन लूज जल्दी करेंगे, जो यहाँ पे होंगे वो इलेक्ट्रॉन गेन जल्दी करेंगे. सो वी कैन काइंड ऑफ लाइक कॉल दिस द ऑक्सीडेशन का ऑर्डर एंड दिस वन वी कैन कॉल इट द रिडक्शन का ऑर्डर. सो ये उल्टा चलता है, ऊपर से नीचे ऑक्सीडेशन करना मुश्किल हो रहा है, नीचे से ऊपर रिडक्शन करना मुश्किल हो रहा है, यहाँ ऊपर से नीचे रिडक्शन करना मुश्किल हो रहा है, यहाँ से नीचे से ऊपर ऑक्सीडेशन करना मुश्किल हो रहा है. Do you get it? मुश्किल आसान का मतलब है takes more energy, takes less energy. Does everybody understand this? Does it mean that if I take calcium, which is better at losing electrons, and I take zinc, which is not as good at gaining at losing electrons, कैल्शियम और जिंक में इलेक्ट्रॉन लूज कौन से जल्दी कर सकता है? कैल्शियम. और इलेक्ट्रॉन गेन कौन से जल्दी कर सकता है? जिंक. इफ यू हैव एवर charged any device, if you have ever used a cell in a remote control, this is what you have done. You have taken zinc and copper, and you have made zinc lose electrons and you have made copper gain electrons. Metal electron gain kar raha hai. Interesting. Let's see. If we take one rod of, let's say, zinc, and we take another rod of, let's say, copper, and I dip them to make a cell. ठीक है? और मैं इसको सिर्फ एक वायर से कनेक्ट कर देता हूं. That's all I've done. I've just connected a wire with them. What will happen? As long as this thing is something that conducts electricity, it is some solution of water. Let's say copper sulfate है. ठीक है? जिसमें ions हैं, freely बिजली conduct हो सकती है. You will see that zinc will give electrons to copper. This will happen. करके देख लेना. Zinc will always lose electrons to copper. And that is what happens here. If you have seen Breaking Bad, उसमें there is an episode जिसमें वो coin से बिजली create करता है. This is what he's doing. He has coins that have zinc in them, और उनसे वो बिजली create कर रहा होता है. So zinc being more reactive, zinc is better at oxidation. Copper being less reactive, it is better at reduction. So zinc और copper के केस में zinc will transfer its electrons to copper. Copper के ऊपर negative charge आ जाएगा, zinc के ऊपर positive charge आ जाएगा. Zinc के ions बन जाएंगे. Zinc becomes zinc ion, and we say that the solid has dissolved and the copper will gain electrons. Now copper can gain electrons here, और वो copper ion यहाँ से वो electrons gain भी कर सकता है. We will come back to this idea when we study electrolysis. But this is at the heart of many chapters that will study electron. All that's happening is a more reactive thing, which means a better thing at oxidation, gives its electron to something that is better at reduction. That's all. It's a simple exchange of electrons. So first step where we see this reactivity series happen, that is electric cells or electrochemical cells. Your battery, phone की बैटरी करती है. आप जब फोन यूज कर रहे हो तो उसमें लिथियम आयंस होते हैं और उसमें यूजुअली कॉपर होता है, और वो इस तरह से कर रहे हैं. लिथियम ज्यादा रिएक्टिव है, कॉपर लेस रिएक्टिव. जब आप उसे चार्ज कर रहे हो ना, आप क्या कर रहे हो? आप उसको उल्टा चलाते हो. आप उन जिंक आयंस को वापस जिंक सॉलिड बनाते हो. आप वापडा से इलेक्ट्रॉन्स लेते हो, उनकी एनर्जी लेते हो, इस रिएक्शन को वापस करते हो. That is when we know कि अच्छा ये चार्जिंग हो रही है. Where else do we see this? Second step, second actual way to figure out कि अच्छा ये चीज reactive है, ये चीज unreactive है. And this idea, the one that I'm going to tell you, it changed the history of the world. It actually did. मतलब insane level पे. This is extraction of metals. Let's say 8-10,000 साल पुरानी बात है, आप जंगलों में फिर रहे हो. You just find a very cool black color की rock. You found this. You don't know it. This is a black color की rock. In the modern world, we need copper a lot. But ये black color की rock है. उस time तो आपको नहीं पता. इंसानों को नहीं पता था ये इसमें से copper निकल सकता है. But here's the thing. Copper over here has lost electrons. Ion है ना? ये ion है, ये oxide ion है. If I look at the charges, so this is +2, this is -2. In the reactivity series, is there anything that can give electrons to copper? Look at the series. Tell me, is there anything that can give electrons to copper? Remember, anything that's more reactive in here, वो electrons देने में तेज है, और anything that is less reactive here, वो electrons लेने में तेज है. So copper यहाँ पे है. कोई चीज जो electron copper को दे सकती है.
Magnesium.
Magnesium, very good. Magnesium is all the way up here. Magnesium is good at losing electrons. Copper is good at gaining electrons in this case. So magnesium copper को electron दे सकता है. There is also the neighbor of copper, hydrogen. And hydrogen का advantage ये है, even though we can use magnesium, we can use copper, carbon, we can use iron, we can use anything here. Anything that is better at losing electrons compared to copper. But hydrogen का advantage है कि hydrogen is a gas. So gas का spray करना बड़ा आसान है. पूरे copper के ऊपर हर तरफ से वो उसके ऊपर spray कर देंगे हम. And that is what we'll do. If I take hydrogen gas and I spray it on this solid, here's what's going to happen. Copper को ये electrons दे देगी. So copper will become copper metal. कैसे? By gaining 2 electrons. उसका charge positive 2 है ना, तो 0 charge पे आ जाएगा. It will gain 2 electrons. And what will hydrogen do? Hydrogen will form H positive. So hydrogen के H positive आ गए. Now in presence of one positive charge, oxide ने किधर जाना है? एक negative चीज हमेशा positive की तरफ जाती है. यहाँ पे on before the
Sir, I
reaction
have a
happened.
question.
Go on.
That oxygen is already giving electrons to copper, so why we need hydrogen for this?
No. Oxygen has already gained electrons from copper.
Okay.
It has already made ionic bonding. वो हो चुका है. Oxygen has formed oxide. वो negatively charged है. But in the presence of hydrogen, hydrogen is better at losing electrons. वो electron lose करना चाहती है. वो noble gas structure लेना चाहती है. वो ज़्यादा stable होना चाहती है. So उसको अपना victim copper ion नजर आ रहा है. It can easily give electrons to copper. और copper भी electrons लेना चाहता है. That is a deal that copper wants to make. So copper is like, हाँ ठीक है, electrons मिल रहे हैं, मुझे क्या है? और hydrogen is giving those electrons away. Better at doing that. So hydrogen gives electrons to copper, and copper takes them from hydrogen and lets it make H positive ion. अब oxide ये सब देख रहा है. Oxide is like, I am a negative ion. मुझे तो जो भी positive मिलेगा, I'll be friends with it. So यहाँ पे before the reaction happened, oxide had copper ion, वो उसके साथ bond किया हुआ है. The moment you get H positive, oxide उसके साथ bond कर जाता है, and you get H2O. To speed things up, we usually heat this. But when you heat this, water becomes steam. It's actually a good thing for us. क्यों भला? आपके पास शुरू में था black powder. By the way, why did I use a powder? Why didn't I just use the rock as I found it?
To increase the surface area so it can dissolve
Very
faster.
good. I wanted to expose it to hydrogen. All the copper oxide, I exposed it to hydrogen, and now they're able to react. और उसका surface area ज़्यादा है, Jasmine I'll say. Thank you so much. So all of this I wanted to react. क्यों? Last week हमने एक chapter पढ़ा था in which we said कि solid को liquid से अलग करने के लिए filter कर लेते हैं. Solid को solid से अलग करने के लिए we dissolve it in water or some other solvent और उसको फिर filter कर लेते हैं. But the problem over here is कि ये भी solid है जो कि insoluble है, and this is also a solid that's insoluble. दो insoluble solids को कैसे अलग करूं? मुझे तो ये method कोई आता ही नहीं है. हमने तो ऐसा कुछ भी नहीं पढ़ा. दो insoluble solids को कैसे अलग करें? So हम एक काम करेंगे. हम end पे इसको रहने ही नहीं देंगे. We will make sure कि एक भी जर्रा इसका बचे ना end पे. जितनी मर्जी हाइड्रोजन यूज हो, we want all of this to be used up. And to do that, what we do is we use hydrogen in excess. So that we have at the end, हमें सिर्फ copper solid मिले. हमें ये solid नहीं चाहिए end पे. गैस हो एक्स्ट्रा कोई मसला नहीं, गैस उड़ जाएगी. वाटर या स्टीम हो कोई मसला नहीं है, वो अलग हो जाएगा. बट सॉलिड और सॉलिड मिक्स हुआ हमें एंड पे नहीं चाहिए. आई वांट जस्ट दिस कॉपर सॉलिड. सो टू डू दैट वी यूज हाइड्रोजन इन एक्सेस. अगर आपने इसका कोई जनरल प्रिंसिपल याद करना है ना, जो चीज आपको चाहिए होती है वो आपने लिमिटिंग में रखनी है. अगर सॉलिड चाहिए तो यहाँ पे सॉलिड एक्सेस में नहीं होगा. अगर सॉलिड चाहिए तो गैस एक्सेस में होगी, लिक्विड एक्सेस में होगा, सॉलिड एक्सेस में नहीं होगा. अगर आपको ये गैस चाहिए तो फिर ये गैस एक्सेस में नहीं होनी चाहिए. अगर आपको वाटर इकट्ठा करना था यहां से तो देन यू शुड हैव द सॉलिड इन एक्सेस. ये एक रूल है जो हम यूज करते हैं. इट्स अ वेरी यूजफुल प्रिंसिपल. ठीक है, हमें देखें कॉपर मिल गया. कॉपर से वायर्स बनाओ, कॉपर से एलॉयज बनाओ, एलॉय से बर्तन बनाओ, फर्नीचर बनाओ, जो मर्जी करो. एंड दिस इज हाउ वी गॉट इनटू द ब्रॉन्ज एज. but at that time they used carbon, not hydrogen. Now, then comes another way. They found another rock, and this one is a much beautiful looking rock. This one is red in color. In fact, red brown इसका color है. Does anybody recall ये कहाँ पे होती है? कल मैंने आपको notes भेजे थे, उनमें लिखा हुआ था. This is found in hematite. ये एक रिएक्शन है, मॉडर्न वर्ल्ड सारी इस पे डिपेंड करती है. कार्बन हमने क्यों चूज किया, मुझे जरा बताएं. आयरन ऑक्सीजन के साथ ज्वाइन हुआ है, मुझे आयरन निकालना है. आई वॉन्ट आयरन टू गेन इलेक्ट्रॉन्स. कोई ऐसी चीज जो आयरन को इलेक्ट्रॉन्स दे सकती हो.
Everything above iron.
Everything above iron. Very good. And in all the things that are above iron, सबसे सस्ता कौन सा है? Most affordable. Carbon. Because carbon is found in coal, and high quality coal उसको coke बोलते हैं. That coke is easily available, easily transportable. It is extremely useful और सस्ता है. So I will just take this. Everything else is more expensive than that. So I will just take carbon here because carbon iron को electrons easily provide कर सकता है. And that's what will happen. Carbon will make carbon dioxide and iron will be left over. So मेरे पास, I'll balance this out. So there you go. Again, this is solid, this is a solid, this is a gas, and this is a solid. It's a more complicated reaction because it doesn't matter मैं ये एक्सिस में लूं या ये एक्सिस में लूं, एंड पे कुछ ना कुछ उसके साथ मिक्स हुआ मिलेगा मुझे. बट फिर भी हम क्या करते हैं, वी यूज दिस इन एक्सेस. क्यों? अगर एंड पे ये और ये मिक्स हुए भी होंगे ना, हम कार्बन को आग लगा देंगे. सस्ती सी चीज है. विल मेक इट, विल कंबस्ट इट, इट विल फॉर्म कार्बन डाइऑक्साइड, वो उड़ जाएगा. दैट इज व्हाट वी डू. ब्लास्ट फर्नेस में यही तो होता है. अब हमें ना आदत पड़ी हुई है ऑक्सीजन के साथ रिएक्शन कराने की. क्यों? ऑक्सीजन के साथ वो बनती है गैस. चाहे वो वाटर है उसकी स्टीम बना लेंगे, चाहे वो कार्बन डाइऑक्साइड है उसकी स्टीम बना देंगे, उसकी गैस बना देंगे. समटाइम्स वी गेट थिंग्स दैट आर वेरी कॉम्प्लिकेटेड कि उसको बाद में सेपरेट करना प्रॉब्लम हो जाता है. एंड दिस वन इज रिसेंटली एडेड टू ओ लेवल सिलेबस. आई थिंक दिस विल बी द फर्स्ट ईयर जो ये सिलेबस में आएगी. ZNS IGCSE के सिलेबस में पहले से है. This is zinc blend. This is the rock in which I find zinc. Zinc has +2 here, sulfur has sulfide -2 here. मुझे zinc निकालना है. That means मुझे zinc को electrons provide करना है. Looking at the reactivity series, can you tell me zinc को कौन सी चीज electrons दे सकती है? Come on, zinc को electrons देने हैं, कौन सी चीज zinc को electrons provide कर सकती है?
Everything above zinc, but we will choose
Everything
carbon
above
because
zinc.
it is
Very
cheap.
good. Very good. So we can use carbon, right? Again, because it's cheap. And we will try to do that. But इसका एक problem है. Again, एक नया मसला खड़ा हो गया. When I use carbon, मुझे zinc तो मिलता है, लेकिन साथ में CS2 भी मिलता है. It's a liquid. And this liquid is not that useful to me. There are other things that I can use and I can sell and I can make more profit. So what I'll do is I'll be like, carbon को बाद में देखते हैं, थोड़े पैसे कमा लेते हैं. Here's what I'll do. And here's what we do. We don't like this ना, CS2 हमें नहीं चाहिए. तो we'll just burn it. कितनी अजीब बात है. अच्छी खासी जिंक आ रही थी, आपने उसे आग लगा दी. आपको इतनी बुरी लगी है CS2. So हमने उसे burn कर दिया. बस उसके पीछे एक wisdom है. This will create zinc oxide and sulfur dioxide. Again, anybody who's read notes from yesterday, where can we sell sulfur dioxide? Sulfur dioxide is a bleaching agent. Any industry that needs something in a very white color, paper industry, हम पेपर वालों को ही बेच देंगे. They will take wood pulp, they will bleach it, white wood pulp बन जाएगी, उससे वो पेपर बना लेंगे. अच्छा, सल्फर डाइऑक्साइड इज एसिडिक, बैक्टीरिया वगैरह को मार देती है. Which industry will make use of that?
Detergents.
Detergents. Really? Detergents? It's a gas. Detergents में gas को डालना मुश्किल हो सकता है. But हाँ, use कर सकते हैं उसमें. फ्यूमिगेशन के लिए यूज कर सकते हैं, बट उसमें अगेन इश्यूज आते हैं कि ये इंसानों को भी नुकसान पहुंचाती है. सो हियर्स व्हाट वी डू. देयर इज एन इंडस्ट्री दैट नीड्स टू किल बैक्टीरिया, और वहां पे इंसान को फॉरन वो प्रोवाइड भी नहीं करनी उन्होंने. दैट इज फूड पैकेजिंग इंडस्ट्री. दे यूज दिस. वो सल्फर डाइऑक्साइड लेंगे, कैन उन्होंने खाना कैन में डाल देना, उसके ऊपर स्प्रे करेंगे सल्फर डाइऑक्साइड का. बिकॉज इट्स अ गैस, इट वोंट डिसॉल्व इन देयर, इट विल जस्ट फ्लोट एंड गो अवे. बट वहां पे जो बैक्टीरिया होंगे वो मर जाएंगे. वो कैन बंद करेंगे, लो जी खाना पैक हो गया. दैट्स व्हाट दे डू. Sulfur dioxide is used in food packaging. It's all in the notes that I shared with you yesterday. And now I'm back to my old habits. Iron oxide के साथ carbon react कर सकता हूँ, copper oxide के साथ hydrogen react कर सकता हूँ. I'm able to get gases. I'm able to get the pure element out. That's what I'll do here. मुझे zinc oxide मिल गया, मैं zinc oxide को carbon से react कराऊंगा. Carbon is better at giving electrons. Zinc is better at gaining electrons. Carbon dioxide बन जाएगा. Perfect. I'm able to get all these metals because of this. And that is what we do here. अगर मुझे हाइड्रोजन से नीचे कोई भी एलिमेंट चाहिए, मैं उसको हाइड्रोजन यूज करके एक्सट्रैक्ट करता हूं. अगर मुझे कार्बन से नीचे कोई भी एलिमेंट चाहिए, मैं उसको कार्बन यूज करके एक्सट्रैक्ट करता हूं. बट कार्बन से ऊपर वाले जो है ना, दे आर क्वाइट एक्सपेंसिव, सो वी डोंट यूज कार्बन. We use electrolysis, which is a much cheaper technique for this. So for extraction, here's what reactivity series helps us with it. कि यहाँ पे हम करेंगे electrolysis. From carbon, we'll do reduction with carbon. And for these, we use reduction with hydrogen. Why? Hydrogen is better at oxidation, and these three are better at reduction. Carbon is better at oxidation. These are all better at reduction. And over here, electrolysis is the cheapest way that we have. It's not as cheap though. काफी उसकी cost होती है, but still the best option that we have. Okay, so here you go. हमारे पास clearly displacement principle हमने use कर लिया. Okay, so दो जगहों पे हमें displacement principle नजर आ गया. There are other cases as well. What if I want to use color change? अगर मुझे सिर्फ पता करना है if something is more reactive and something is less reactive, and I want to see that, so I can use color change. Can I use it in metals? Are there any metals that show color change?
Yeah, yes.
Which ones?
Transition metal.
Excellent. Transition metals, they show color change. So here's what I will do. Let's say मेरे पास ये solution है copper sulfate का, और मैं इसमें जिंक का एक ब्लॉक ऐड कर देता हूं. क्या होगा? Copper sulfate has copper with +2 charge, sulfate has a -2 charge, and zinc has a 0 charge. We have seen this before. यही चीज हमने यहाँ पे देखी है हाइड्रोजन केस में. ये चीज हमने देखी है ना सल्फर के केस में. यहाँ पे भी यही होगा. Zinc is better at losing electrons. Copper is better at gaining electrons. So zinc will lose electrons to copper and make zinc sulfate. And copper will gain electrons and make copper solid. Now let's look at the colors. Copper sulfate, this solution is actually blue in color. It's a very beautiful blue. Zinc is gray solid. Zinc sulfate is colorless. And copper is pink. तो अब देखोगे थोड़ी देर बाद zinc will dissolve because पहले solid है, अब solid नहीं है. बाद में zinc solid नहीं है ना, तो zinc dissolves. And there's a solid being made. Pink solid. Pink solid appears. You will actually see it. Pink color का यहाँ पे एक layer सी आ जाएगी. And the blue color also fades. What is all of this telling me? ये blue color खत्म हो जाएगा थोड़ी देर बाद. This is basically telling me that the more reactive thing has displaced the less reactive thing. Copper was better at gaining electrons, zinc was better at losing electrons. zinc ने electron lose किए, copper को दे दिए, copper ने electron gain कर लिए. हाँ, copper ion ने electron gain किए, copper metal electron gain नहीं कर पा रहा. कॉपर आयन ने गेन किए. So we can use this color change. So we can say that the color at the end is usually of less reactive substance, and it is solid for most metals. There is one metal which will not be solid, that is mercury at room temperature, but the rest of them will be solid. So as you can see, the solid that we had was copper at the end, clearly because it's less reactive. Can we use the same idea of color in nonmetals? We can. Group 7, they're all colored halogens: fluorine, chlorine, bromine, iodine. Tell me, what are the colors? Fluorine का color क्या है? Yellow gas. Chlorine का color क्या है? Yellow green. You can also say green, that will be acceptable. Bromine is red brown, but IGCSE people usually can write orange. O levels वाले भी orange लिख लें, कोई मसला नहीं. It's a liquid at room temperature, and iodine is a black solid at room temperature. बहुत dark black नहीं होता, it's gray black. But if I dissolve it in water, it's brown, so it's a brown liquid. And if I evaporate it, it's purple gas. Okay. Now, fluorine has 2 shells, chlorine has 3 shells, bromine has 4, iodine has 5. Which one will be good at gaining electrons? Smaller atom. Because smaller atom has greater attraction, it will gain electron faster. Larger atom has weaker attraction, it will lose electron faster. So fluorine is good at reduction. Electron jaldi le sakta hai. Iodine is good at losing electrons. Electron jaldi de sakta hai comparatively. इन सब में पॉजिटिव आयन के साथ हम चेक कर रहे थे. अब हम नेगेटिव आयन को चेक करने लगे. So here's what I'll do. Let's say I have hydrogen iodide. This is hydrogen iodide. We talked about nomenclature. उसमें हमने पढ़ा था कि HI on its own is hydrogen iodide. But the moment I dissolve it in water, it becomes hydroiodic acid. Okay? Acids are colorless. मैं इसमें bromine add कर देता हूँ. Does bromine exist as this? Can I find Br in nature? I can't. It exists as Br2. तो मुझे Br2 मिलेगा. But over here, I'm comparing it with this thing. Iodine has a negative charge, so yeah, iodide hai. This has a 0 charge, this has a positive 1 charge. Bromine is good at gaining electrons. Iodide is good at losing electrons. Right? Iodide is a good oxidizing agent. Bromine is a good reducing agent. Sorry, ulta bol gaya. Bromine is a good oxidizing agent, and iodide is a good reducing agent. So that's what happens here. Bromine will take electron from iodide. Why? Because bromine is a smaller atom. So it will form HBr. Why HBr? Because bromine ne to negative charge karna hi karna tha. So hydrogen positive, it will just go with that. And iodide will become iodine. You can balance it out. What will be the color change? We will see red-brown color change to just brown color because it's happening in water. So the color change shows that iodine bahir aa gayi hai. It's less reactive. Let's try the same thing with HBr. I take HBr, I add chlorine in it. I get HCl, right? Because Cl can easily gain electrons. Br can easily lose electrons. So Br will give electrons to chlorine. It will form HCl. I will get bromine out. Just look at the charges. Positive 1, negative 1, 0. Positive 1, negative 1, 0. You can clearly see negative से 0 पे आया electrons lose किए हैं. 0 से negative पे आया electrons gain किए हैं. So clearly the color change is going to be there. Green color changing to orange color. The orange color shows that this is less reactive. So color change is another way through which we can figure it out, and not just for non-metals, also for metals. In सब के पीछे एक ही चीज है, displacement principle. We will continue with this. Displacement principle is everywhere. There are more ways through which we will see this. All right. Thank you so much. Take care. See you tomorrow. Allah Hafiz.